Hello. In this video we're going to work through number 12. I haven't actually done this problem yet, and I thought about doing it off on paper first and then, doing it for a video, but I think it's really good for people to see me work through a problem from scratch, just to kind of get a feel for my thought process and how I approach a problem. So let's dive in, shall we? So ABCD is a quadrilateral. And if you're asking yourself what a quadrilateral is, I'd say the first step in this problem is to figure that out. I'll tell you, a quadrilateral is simply a four-sided shape. But if you didn't know, taking a second here and jumping online and looking that up or using any reference text is really important. So given A is 3, 0, B is 0, 4, C is negative 5, 0, and D is 0, negative 4, find the area of quadrilateral ABCD. So I'm definitely going to start this problem by drawing a sketch. And luckily I have the grid up here, which is really nice. So since I have the grid up here, I'm actually going to give a scale diagram. Let's see if I have enough space here. We'll find out. So A is 3, 0. So 1, 2, 3, 0. So this is A. I'm going to be sure to label my points here. Very important. B is 0, 4. 1, 2, 3, 4. That's B, which is 0, 4. C is negative 5, 0. 1, 2, 3, 4, 5. So there's C, negative 5, 0. And D is 0, negative 4. 1, 2, 3, 4. So there we go. And now I'm going to connect these. And be sure you're connecting them in the order that they're written. So I'm going to go from A to B to C to D and then back to A. So there's my quadrilateral. Now there's lots of ways to do this again. We can look inside the shape, and what I mean by that is we can look inside and try and break this up into shapes that we can find the area for, or we can look outside, and what we mean by that is we can extend some lines and turn this into a giant rectangle and then find some areas and subtract. My first solution here is I'm going to look inside, and then I'll do it looking outside, and we'll compare and see if we get the same answer. So what I'm going to do is I'm going to grab a different color here, and I'm actually going to go and try and cut this up into shapes I can work with. And what I notice right away is I could do this. If I kind of do this, what I see is I end up with a nice right angle triangle right here, and a right angle triangle right there, and a right angle triangle right there, and a right angle triangle right there. I can find the area of 4 right angle triangles pretty quick. So let's call this triangle A, B, C, D, just to kind of work through. So 4A. So let's say the area of A is going to be 1/2 the base times the height. So the base here is 1, 2, 3, 4, 5 times the height 1, 2, 3, 4. And this is going to give me a total area of 10 units squared. Okay, let's do B. So the area for B is going to be, well, let's, again, 1/2 base times height. 1, 2, 3, 4. 1, 2, 3. So it's going to be 4 times 3, which is going to give me 6. So now let's look at for C. So the area of C is equal to 1/2, again, base times height. 1, 2, 3, 1, 2, 3, 4. Well, that's the same again as the last one, so that gives me 6. And now let's do 4D. So the area of D is going to equal, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1/2, 5 times 4, which is 10. What jumps out at me here as I'm doing this is there's a lot of symmetry in this problem. Something to think about. So then, that means the area for A, B, C, D is equal to the sum of area for A plus the area for B plus the area for C plus the area for D. And so that's equal to 10 plus 6 plus 6 plus 10, which gives me a grand total of 20, 32 units squared. So now that I've done this, let's do this in a different way and see if we get the same answer, shall we? So I'm just going to pause it and reset up here. So just bear with me for a second. Okay, so I've redrawn this out. A little rough, mind you, but I've drawn it out nonetheless. So again, like I said, one of the strategies is we can look inside or we can look outside. So the last time we looked inside by chopping up into smaller shapes. Now let's look outside. So what I mean by that is what we're going to do is we're going to extend these out. And what we want to try and do is we want to create right angle triangles. So if I do this and then I keep coming down here, come across here, come down here like this, come down here across here like this, come across along the top here like this, come down. What I've done is I've created this giant rectangle now by extending the shape out. So I can of course figure out this point. So this point is going to be negative 5, 4. I can figure out this point. This point is going to be 3, 4. I can figure out this point. This point is going to be 3, negative 4. And I can figure out this point here. It's going to be negative 5, comma, negative 4. Let's, instead of doing a whole bunch of work, let's do this right on the graph, shall we? So let's see. So this is a length of 4 units. This is a length of 5 units. This is a length of 3 units. This is a length of 4 units. 4 units. 3 units. 5 units. So the total area. So let's give this E, F, G, H. So therefore, the area of E, F, G, H is equal to 5 plus 3 is 8. 8 times 4 plus 4 is 8, which is equal to 64 units. So that's the area of the giant rectangle. So now, let's figure out the area of each of these rectangles and pull them off. So let's, sorry, not rectangles, triangles. So this one is going to be 1/2 5 times 4, which is going to give me 10. This one is going to be 1/2 3 times 4, which is going to give me 6. This is going to give me 6 as well, because 1/2 3 times 4, which is 6. 1/2 5 times 4, which is 10. So therefore, now what we can say the area of A, B, C, D is 64 minus 10 minus 10 minus 6 minus 6, which is 64 minus 32, which is equal to 32 units squared. And sure enough, same answer. So I'm sure once you look at this question, you say, oh yeah, it's pretty straightforward, it's not too hard. I would say the bigger thing to take away from this problem is that if you're given some shape and you want to find the area of it, you can think about breaking that shape up into a bunch of smaller shapes, or what people think of less often is extending that shape to kind of add to it to make a shape that you can easily find the area of, and then you can subtract the added components. Anyways, I hope that helped. Have a good day.